Welcome to the Science Hangout. Today is day number 5 of the Science Hangout. Yesterday's Science Hangout incurred 42 clicks on the science counter. We're going to reset that right now. Boom, back to 0 on the science counter. Click. So remember, today and every day in the Science Hangout is all about science. Now, what is science? Science is everything. It is the air we breathe. It is the dye in the clothing we wear. Science are the questions we ask that we take the time to explore closely, making observations, recording and writing down what we've observed. Science is trying something new, seeing what happens. And if it didn't work out the way we thought it would, trying it again. So is science filled with mistakes? Sure. That's okay to make mistakes. That's how we learn. If we knew everything and we never made a mistake, we'd never be learning. And that would be sad. That would be sad, sad, sad. And nobody likes to know it all. Nobody likes to know it all. So it's good to ask questions and say, I wonder, let's give it a try. So yesterday on the Science Hangout, we made a paper airplane that's supposed to be like one that flies really far. And I put the link to where to make the plane, the professional plane maker person, in the Trello board information card. So moms and dads, you can go to the Trello board and look at Thursday, and you can find a link to a man who takes 8 minutes to make this plane. So, or you could just watch the Science Hangout again and enjoy me telling you about it. I talk a little faster than that person. Maybe good, maybe not good. So I'm going to try throwing it across the room, and I'll just tell you what happens. I'll make observations. Science, it went pretty well. It kind of had a steady downward arc. It did not have any lift, which reminds me, one of the things I'd like to be able to say to us all about whenever we have something that's flying is there are four fundamental forces that are involved with flight, right? Anytime something is going to move through air or a gas. And the 4 fundamental forces, yesterday I had this tube. Here's another one, an amazing flying tube. There's 4 fundamental forces. And the first force is thrust. That's when we put energy of forward motion, right? So thrust is a forward motion energy. Something's going to fly. It's got to have some forward motion energy. It has to. So thrust. There's another force that acts on things. Anytime you're going through the air, there's aerodynamic drag. So we call that just drag. And as something's going through the air, the front edge and the parts of it are hitting against air molecules. Remember, air doesn't look like it's made of much until it starts moving really fast. And then we know it's made of stuff. I mean, when you have air moving 100 miles an hour and it's hitting trees, those tree branches start to fall off, right? So air has quite a bit of force. And that aerodynamic drag, that all you need to do is when you're driving down the road, stick your hand out of the window of the car and it goes back, right? Or you ever stick your hand out and do this kind of thing with your hand out the window of the car and make it feel like it's a plane kind of riding the air, and then you do this and the hand goes back, right? Of course, you got to watch out for trucks going the other way. I once saw a scary movie where a guy's hand got hit off by a car passing the other direction, and then the hand stayed alive and it would crawl around at night and try to find its owner. And it was really, it was before computer graphics. It was really poorly done. But it made an impression on me because I was probably 10. I don't know if I should be watching scary movies about hands that crawl around looking for their owner when I'm 10. So anyways, so we have thrust, we have drag that works in the opposite direction of thrust, and it's from air molecules hitting the object. If something is going to stay aloft, it has to have lift, right? Lift is what makes it go upward. right? It's an upward force, and then it's got to have, it experiences the force of gravity, and gravity is pulling it back down to the earth, right? Gravity is a force experienced between all objects, but generally not felt until objects get huge, like the size of a planet. But there is gravity between you and your house. If you are 50 feet away from your house, there's going to be less gravitational attraction between you and your house than if you're 10 feet away. But it's so weak, it's so minuscule that you can't feel it. You cannot feel the gravity that is really there until things get big. I once sat on an airplane next to a man who worked for the Air Force, and he flew specialized planes that would go over the landscape and mountains and lower areas, and they would measure the microgravity adjustments, because even on the earth, the gravity shifts to tiny amounts based on where you're at. If you're down low in a valley, more gravity. If you're up high on a mountain, you're further away from the main mass of the earth, you're going to experience a tiny, tiny, tiny bit of less gravity. You won't feel it in your body, but it exists. So we have the 4 forces of flight. We have thrust, drag, lift, gravity. And that's it. So I made this one. We flew it yesterday. I want to show you what I made also from a cardboard tube. I basically took the small tube and I took a piece of cardboard. Let me see, there's some leftover here. Leftover. Oh, like this. And I cut it into a little thin strip, and then I put it around this one and taped it and turned it into a little bit of a more sturdy, amazing flying tube. Can you see that? Take a look, Trevor. Take a look. See that amazing flying tube made out of cardboard? I haven't tried it with a bathroom toilet paper roll yet, but you could certainly try that with a toilet paper roll. Something like this. Oh my gosh, look at this one. There's meat on them bones. Do not throw. Who threw this away? Who got rid of this toilet paper roll? You could have seriously, in the great toilet paper hoarding of 2020, somebody's going to get in trouble. I don't know who did this. They are not doing all right. I mean, this is when it's time to get rid of that. So try it. Try it with the toilet paper roll. Worked good for me. So let's talk a little bit about this cup and what we're going to do with that. We are going to put water to a high level. And then, this week, like I said, is all about fun things you can do with cardboard. And one of my favorite science tricks is it a trick? Maybe. Is it magic? Maybe. Well, one of my favorite demonstrations. Oh, did I say science? My favorite science demonstrations, 15 on the science counter. We need more. Hey, can you guys help me out on the science counter? I'm going to unmute you and I need some help here. Can you help me out?
Science.
Wow. It almost sounds like a flock of seagulls or something somewhere. You come across them, it's like science. I don't know. Whoa, we got us up to 41 though. Not bad. Okay. Okay, where was I? I was talking about a science demonstration. And this is the reason I like this is you can do this demonstration anywhere. You could do this demonstration at your grandma's house. You could do this demonstration when you're out at a restaurant and you're not under stay safe at home orders and you're not having to be physically distanced by 6 feet. So in the meantime, since we can't go to the restaurant to do it, whoa, I'm seeing that face. That's interesting. Sorry, somebody put a really, really weird face up on their screen. Distracted me. I love it. Since we can't go out and do those things, we have to do it at home, which is a good place to practice because with this science demonstration, there is a possibility that you make a mess, right? If you don't do it right, you could have a whole cup full of water on the floor, on the table, and then yeah, that's a mess that somebody has to clean up. Ideally, it'd be you that's cleaning it up, because it's nice to help people out by cleaning up our messes, right? But if we're out at a restaurant, of course, then maybe the waiter, the waitress is cleaning that up, and it's a lot of work. It's a lot of work. So get your cup, get some water, or if you want to try it over I'll do it first, and then you can try it over your kitchen sink. Okay. So I'm gonna move the camera. Actually, I think I can do it right here. Okay. Let's see. My Beetle book. Beetlejuice. Okay. Yeah. Okay. Cup. Water. Santa Barbara Yacht Club, anyone? Santa Barbara Yacht Club, anybody recognize this water bottle? It was left at RTS. It's a lost puppy. By the way, some of y'all need to spend some time and come back to RTS and pick up your jackets. Anyways, that's all I'm saying. Okay, water in the cup. And watch this. I love to do this. Where are we at? Ready? Ready for the pour? Wait. If you can add a little of that razzle dazzle as you're pouring, bring it up and keep the pour going into the cup. That's nice, right? That's nice. You want to be able to do a little of that every now and again. And I'm going to bring it up pretty close to the top. I'm going to put the water over here somewhere else. I don't have to worry about it. I'm going to try not to knock over the cup with my gesticulating hands. Gesticulation. Today's science hangout is brought to you by the word gesticulation. To gesture. Okay, got my cardboard. Ooh, that's a nice sound. Let's listen. Okay. Now, right now, nothing holding the cardboard on. Gravity makes it fall on there. There's water inside, and there's a little bit of air right here at the top. Just a little bit. Okay. Now, you put the cardboard on. You hold it in place. You turn it over. This is the part where it gets a little scary, right? This is where you have to trust. You could, if you want to be a show person, you could say 3, 2, 1, abracadabra. And you could take your hand out. Whoa, wow. Okay, look at that. You take your hand and say, wait a second. What sort of sorcery and witchcraft is this? No sort of, look at, there's water on here. See, it's getting wet. No sorcery, no witchcraft. Let's try it again, just to make sure that, I got no tricks, I mean, I got lots of tricks, science tricks. Okay, boom, on top, hold it in place, nice and flat. And notice it's a decent piece of cardboard. Does it have to be corrugated? No. Could it be that thin stuff that you get from a cut up cereal box? Yes. Should it be paper? Probably not. I'm going to do the finger wag of science. No, paper will not do. Science. Where is it? Science. 49. Oh, let's just science 50. Okay, now, but let's try and, I see Memphis has a hand. Memphis, I am going to unmute you. Speak, great Memphis.
Jim, last science class you said maybe today I could show you guys how to make the dart airplane.
Thank you for the reminder. You are going to show us today, Memphis.
Yay! I tried to show
an airplane today.
I tried to tell you in the chat, but nothing came.
No, well, that's because Daniil was cramming up the chat with a bunch of hi. Thank you, Daniil. All right, back to the thing at hand. I'm going to mute you again, Mem. We're going to do this activity one more time, and we're going to talk about what's going on in here. Okay. Actually, I'm going to bring this up. Oh, we can see the periodic table again. One of my favorite things. Okay, remember, here we are. We turn it over. Bubbles come to the top. Ooh, ooh. And we take our hand off. Nothing underneath. Whoo, whoo. Right? So now what's happening, I just want to explain what's happening. So we understand, we don't just say, somebody says, well, that's cool. What goes on? You say, I don't know. That's not cool. If you just say, I don't know. What's cool is if you share what you know. Now, they may not want to hear it, in which case, you know, you don't have to share it. But if they say, so what's happening, you have to say, the air pressure on the bottom of this card is greater than, the air pressure is greater than the force of gravity pulling the water down, and the air pressure inside has decreased. Normally the air pressure outside and the air pressure inside would be even, but because this is pulled down a little bit, it's made more space for this thin little bit of air in there. You can see it. You can see that little air pocket. There's less air molecules in there in terms of their density and how much space they take up than there is down here. So this is crowded with air molecules, and this is very scant or sparse or limited in the air molecules. And the force of these air molecules has enough pounds of force because of the way they collide with the surface, the way they collide, they're bouncing, 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 that it's greater even than the weight of this water, which is not nothing. I would say the weight of this water, maybe about a quarter pound. So there's at least greater than a quarter pound of air pressure. In fact, if we made this a vacuum, there's a lot more than a quarter pound. So, all right, I'm going to turn it back over. Ooh, lost a little water there. And we take it off. One last time because it's so cool. But you got to be careful. You can't be too crazy with this because it could slip off, and then you got water everywhere. So that is a great thing to do with a piece of cardboard. When you have a piece of cardboard, you know what it works really good with? Some restaurants have these little pieces of cardboard called coasters, and you can use a coaster. I see some hands. I'm going to get to you in a second. First off, did anybody try this? Did anybody try this at home yet? Not yet. You're going to try it. You tried it? Oh, look it. I see here. I'm going to spotlight the video. Hold on. I'm going to spotlight the video. I'm going to show you guys. There we go. All right. I like how you've got it over the tub. Are you going to try it?
Yeah. Okay. They can hear you. Okay, go. Okay. Hold on with this hand. Uh-oh, we're leaking.
It's okay. A little leaking is okay.
Let go of this hand.
You just got to hold it flat. I see it's curving, Mom. It's got to be, the cardboard cannot curve.
Okay. I think it's too late.
Oh my. Woohoo! Look. Oh. Good thing you guys, good thing you had a bucket. Good thing you had a bucket.
That's great.
That was amazing.
Yeah.
Oh my gosh, you guys. Thanks for sharing that with us. Oh, wow. That was amazing. We love to see that. I love that was shared by Johannes and Tian. That was so cool. If you ever want to share, was Trevor, are you going to do it? Trevor's got to set up. We're going to let Trevor share his demo. Hold on, Trevor. I'm going to unmute you. I'm going to spotlight the video. Hold on. Okay, so, Trevor, you're live.
I'm just really scared.
It is scary. I bet it's scary for your mom.
Now you got to hold it down and tip it over. Keep that cardboard nice and tight.
It's got to be flat on the surface.
Got to be totally flat. Oh no. Okay, hold it. Now you're going to let go of the bottom and see what happens.
I hope they had it under a bucket under it. Oh my gosh, you guys. This is this is making great content. I'm telling you, the Science Hangout is on the rise. Our vlogging potential has increased exponentially. We are not on the Science Hangout. We do not want to flatten the curve. We want to increase the curve of the science content. I hope everything's okay over there at Sunday. I hope the computer keyboard is not underneath that one. You all right?
Yeah.
We have a towel.
Okay, good. Oh man, that was.
Do you know what is science? Do you
What?
know what is science?
What?
Minions!
All right. Wow, that was too much fun. I can't believe I get to do this for a living. This is beautiful. Okay, you guys. So practice over the sink. Practice. Most of the time when I've been a science teacher or an experimenter in my own life, I've practiced the demonstrations I was going to do first before I did them in front of the whole class. Now, many of you who know me and who've known me over many years, I said science teacher, didn't I? Many of you who've known me for a while know that sometimes I get so excited by a question a kid asks, and when they share a demonstration they might have seen on a video, that I just go ahead and try it. Or we come up through our conversation with a way to test something out, and I just do it. And it doesn't always work out. It doesn't work out. I've had many a moment with a live audience of kids where I've done the same thing that Trevor just did, and it all fell and it got on my clothes or something. And of course, as you know, if you've ever been in a regular class, or as you can imagine, if I was, if you were here at RTS in the design room, you'd be cracking up. I mean, kids cracking up, falling out of their chairs, laying on the floor, kicking their legs in the air, like Peppa Pig's family at the end. If you've ever watched Peppa Pig, when they all start laughing, then they all go on the ground and they start kicking their legs in the air. You Peppa Pig watchers know what I'm talking about. I mean, kids falling out of their chairs, laughing, I hope with me, not at me, maybe a little at me, but with love, right? With love. We all make those mistakes, and we have to have a sense of humor about it. Sense of humor is really important, right? Yeah, Memphis knows. Memphis has a great sense of humor. So, yeah, Trevor, that was beautiful. Okay, Memphis, everybody, our dear friend Memphis is going to show you how to make his aeroplane that's going to use thrust. It's going to experience a force of drag. It's going to experience a force of lift, hopefully. And of course, it's going to experience the force of gravity. So Memphis, without further ado, I'm going to hand the Science Hangout over to you. And we're going to spotlight you, my friend. Ladies and gentlemen, our dear friend.
You ready?
Sky, Memphis.
Okay. So what you need for this is a sheet of paper. And what you're going to do is take the paper lengthwise and do a hot dog fold.
Hot dog fold, lengthwise.
So fold it in half so you can get that crease. It doesn't have to be perfect, but better and then you take one corner and you fold it in until you hit the crease. Like fold it in towards the crease to create that. See?
Mm-hmm.
Do that. And then do it on the other side too. And what I like to do to make sure all my folds are clean is fold it, do this, fold it now. Once everybody's done that, just say you're ready for the next step.
Hold it
Nice,
up.
Jim.
Yeah.
Nice, Jim.
Thank you.
Nice, Daniel. Savannah's done it. Daniel's done it. Jim's done it. Good job, Johannes. So the next step is taking one edge and folding it onto the crease like that. See? Okay. Fold it like that. So you get, and then do the same thing on the other side. So that when you fold it up, when you fold the both halves to touch each other, you get this shape, a wedge. And then you do the same step again on each side. So that step you do twice. 2 times on each side. And then you can trim your nose to fit. Or you can trim your like nose and stuff. Once everybody's got to this, let me know. That's it, Johannes.
Sorry, I'm almost there.
Trevor, you're close. You have this. But what you need to do is do the same step again. The step you just did, but do it one more time. Johannes got it.
I'm almost there, man.
Whoever
Oh.
science rules is.
Oh, science. Science.
Whoever
63.
science rules is, you have this. You need to fold that one more time so it looks like this. Okay. Got it. You got that? You got it, Savannah? Oh, let me help you. So, Savannah, since you're right over there, look at what you have is that. You need to take this like that, fold. So when you fold it into half, get a dart shape. You can do it. Now, do you have it? Do you have it, Leon? Do you have it, Jim? You guys have it?
Yeah, I have it. And then I have to fold it this way to have it like this. Is this?
Well, yeah. What you do is you have it.
Oh, are those on the inside?
No, this is the outside. You have that. You start with that, and then you fold that in, and then fold that in, and then fold it in half, so you get this really long dart shape.
Okay, I think I got it then.
Once you figure it out, it's super simple. Because like there's only one more fold after this.
Okay.
And then you fold out the wings by bending both the sides in half up against the edge of the paper. Then you can use your scissors to trim the nose if you like.
Oh, you trim the nose maybe?
You can if you want to.
Good.
If so, you're going to want to trim like that much.
Woo! That's a good test flight. That worked good.
Yeah, so when you're done, you should have something that's really long and skinny. And then you can use some tape to hold the 2 wings from going apart, if you want. Is this it? That's pretty close. Really close, Spenny. You're doing really good. Is it finished? All you need to do is...
Johannes has a question. Johannes, I'm going to unmute you. What's your question, Johannes?
What is it?
Which way how do you fold like the outer wings?
What you do is you start with this, because you have this, and then you bend that down. You bend that down and bend that down, so you get this, and then let them spring back up like that.
Okay.
So you're very close, Nana. I'll fold another so you can see. If anybody else has a question, just send question through chat. So what you do, Nana, is you fold it in half, right? I'm showing you. And then you fold the two corners in. Yeah, you can take one, so you fold the two corners in. And then you fold, yeah, this is how you do both sides. Fold this in, fold this in again. You see? You see? That you. Okay. What is it, Daniel? You said you had a question? Go on and Jim, unmute Daniel. He has a question.
Daniel, unmuting you, my friend. Where are you? Oh, there you are. Unmute. Go, Daniel.
And whoever science rules is, it's not the same thing you're talking about. It's super skinny, and it's supposed to go really fast. Essentially, yes. You're very, very close. Actually, yeah, that's it.
Science rules.
I heard it.
In second, this is what I've got. I have no idea what else to do.
Where are you, Daniel? Oh, that's actually, it's supposed to end up like this, but that's pretty close because everybody's doing that, which is just this. Not what you need to do is here. I have a demonstration paper. You start with this, right? You fold in the corners like all airplanes. You fold in that, and then what you need to do is fold in that again.
We did it.
You need to do that third step twice.
I know. We did.
Yeah. So just do that twice, and then you'll have, and then all you have to do after that is the wings.
And this is what we have. That's
And I see you used a little tape to kind of hold it together in the middle. Is that right?
Yeah, because this particular one, it has such thin little pieces in certain areas that it does sometimes, depending on how well it's folded, it does sometimes need a little tape to keep from springing apart in flight.
Yeah, there's a lot of stuff in the middle too, right? A lot of paper in there.
Yeah.
You can only fit so many pieces of paper together.
I have one more question.
Yes, Daniel.
Science.
Daniel, how'd you do that? Ooh, 74. That's what I call a good day.
Jeez, the science counter is filled with science.
Science counter filled with science. What's up, Leon? Leon needs to speak. Leon, you are
Leon.
Science.
Got you. I got you, son. So I point over there because that's where I'm looking at. You're in a little square right here on my screen.
What, Nana?
Who? Somebody else? Daniel?
Yeah, that's it. You did good. You
7
just
new
did it.
messages in the chat. Johannes and Tian said, my plane flew really well, Memphis. Great mention today.
Yeah, that's great.
That is
It's
a really
slightly
nice
different,
speech.
but that'll fly really good too. That's another one.
Nice.
Anyway.
Oh, I see Trevor. You're unmuted, Trevor.
Trevor?
What's up, Trevor?
That's good.
Oh, here can you
Show me
speak
the
to
wings. Oh my gosh, Trevor, you got it. That's it. That's the exact same thing.
Nice.
That's it.
Trevor.
It works really good.
So, ma'am, I'm gonna give mine a try. I'm gonna fly mine.
Go on ahead, Jim.
I'll let you know how it goes. Holy cow!
And also science.
That's pretty good actually. Look at it. See?
Oh, that thing really is a dart. Is that what you call it? Is the dart plane?
Yeah, I call it the dart.
That's a great name for it. It really is. That is beautiful. I'm gonna take back the spotlight. Spotlight. And I heard a bunch of science. I probably heard another 10 or 12.
Science.
98.
Science.
So, 103. Science. Whoa. So we beat our original record of the first day of the science counter, which was day 3 of the show. So that's pretty good. I'm proud of you. I'm so proud of you, children.
My whole goal, all these science things, is trying to get to 100.
Boom. And the other thing is we're doing great on our attendance, our viewership, our participation. I really love that Memphis brought something today, and I want to encourage any of you that want to share something on our Science Hangout to bring that. And you can do just as Memphis did and teach us, because we're all learning from each other. And so bring your favorite activities. Next week, we are moving away from paper and cardboard, though continue
Why?
to experiment with them, because we're going to move into the land of chemistry. We're going to find some more at-home chemical experiments that we can do.
Oh, Jim,
Yo,
speaking of chemical experiments, I did a chemical experience with baking soda, vinegar, lemon juice, and lime juice. Lemon juice and lime juice have the same reaction as vinegar. That is, yeah, it's really cool. And it puts out a candle too. So it's really cool. I did that.
Puts out the candle. So we're going to do some more of those kinds of things next week. And maybe we'll also, just like we did today with our cup water, we did that to kind of be considered an air pressure demonstration. We'll do some of those as well. So it's now time for me to end the science show. Today's show, we made the Dart airplane with the help of Memphis, and that thing really flies well. We took a cup of water. Oh, right here. We demonstrated air pressure. It's pretty strong. Well, I don't know about this one. It actually has a crease in the cardboard. I'm going to go like this. Oh, it doesn't want to hold. This one. So,
Go, Jim.
cardboard's got to be perfectly flat. It can't have, see that crease? It wants to leak out.
Science rules.
Science does rule, and life rules, and taking care of each other rules.
And RTS
Unmute
rules.
Ian, Johannes, you can unmute yourself now. There you go. What do you want to share, Johannes?
Never mind.
Oh, next
Hey.
time. Okay, you guys.
Yeah,
I have to say
Jim.
goodbye for now. You're all welcome to stay here and hang out. We're going to be back in this room in
Jim,
10 minutes.
Jim, really quick.
Tours. What, man? What?
When you leave, could you make me host?
I think I probably can. Hold on a second. Let me find you. Wow, that's a big request, Memphis.
Okay, to do the.
What is your RTS rules?
I'm gonna leave. What now? I'm gonna be host.
You're the host, Mem.
Okay.
Have fun. Be nice.
Okay.
Take care,
So-
everybody.
Danielle